interactive, so I'm going to go quickly, but if you come across something you want to ask questions about, please don't hesitate to raise a question. So without further ado, let me get presentation started here. I'm assuming you all can see that okay, Emily?
Yep, it's perfect.
Okay. So what I want to cover is a little bit about the enterprise blockchain and a little bit about Oracle's strategy around enterprise blockchain. Then I'll talk a bit about the blockchain platform capabilities and what we did to improve the experience in terms of using and creating blockchain applications. Then I'll talk about some customer use cases and partner solutions. I will mention I'm a technologist, so and this is not a heavy technology session. By any means. It's more business focused, and I will try to address that as I can. Some of these use cases I'm more familiar with than others when we get down into the use cases. But please don't hesitate to ask questions, because it sounds like a lot of you are supply chains experts, which is way beyond me. So, so a little bit about some predictions, and these predictions are about a year old. So you can read these. We're expecting dramatic growth, and we've seen dramatic growth in blockchain adoption. Pretty much every large corporation has at least some sort of a POC going on, a pilot, or actually in production. And as you know, Brian Behlendorf, he's the executive director from Hyperledger, which is a part of the Linux Foundation. And he's saying here, if you're in the diamond business and your diamond is not registered on the ledger, you might have trouble reselling it. So keep that in mind for any engagement rings that are being purchased. Just a thought. So what is blockchain? Hopefully everyone here knows this, but I'm just going to go through some real quickly. So basically it's a means to maintain a set of distributed ledgers in a peer-to-peer network. So the advantage of this is that being peer-to-peer, the information is replicated in real time, and using blockchain technology with cryptographic links, the records that are in the blockchain are unalterable and are replicated to each of the participants. And one of the big advantages of this is that you can then have parties that don't fully trust one another to be able to participate in a business transaction. So normally that's done through intermediaries, and what we'll see is that can be eliminated by using blockchain technology. So, so the whole idea here, basically, you have this idea of a smart contract that embeds the business logic that's agreed upon by the participants in the blockchain. And one thing I should mention, I'll have a slide on it, but I should mention here that Oracle's really only focused on permission blockchain. So if you're here for Bitcoin, I have nothing to say. If you're here for enterprise, business to business kind of applications, this is the talk. So we are only focusing on permission blockchains because generally the parties involved in business to business transactions need to know who they are. And most of the other blockchains allow things like anonymous participation or unverified credentials. So, a little bit about why the properties of blockchain tend to impact businesses, and it's largely because we can accelerate business. You can do things much quicker. You can avoid things like settlements and risk as well. You can reduce that. You also can do things like, as I say, eliminate intermediaries, right? So normally in a trade finance situation where I want to buy something and I want to make sure the supplier, delivers it, so they get partial payment, maybe order the materials, they get another payment on partial delivery and full payment on full delivery. All those interactions generally go through a set of intermediary banks. And what blockchain allows is for that to be eliminated, and essentially these agreements to be executed automatically in an algorithmic manner. You get transparency because the ledger is distributed across the various participants. We mentioned it's irreversible or irreversibility. A lot of people like to use the term immutable. I don't like to use that term because nothing is immutable except write-only memories. And we write once memories, and we don't generally use those. So things are mutable, but the question is, can the mutations, the alteration of the records be recorded? And what blockchain does is allow, by the cryptographic hashing mechanisms and linking those hashes together, prevent the ability to be able to change the records without notification or evidence. So you get this tamper-evident ledger of all the transactions. So you get a combination of cryptographic primitives, things like signatures to be able to prove the authenticity of who signed something. You use hashes to be able to verify that things have not changed. And then as well, we're using distributed systems. So we use peer-to-peer networking to be able to speed up the processing and reduce latencies. Gartner makes this analogy, which I think is a good one, especially if we have a lot of customers right now who are looking at how to break up their traditional applications into smaller applications and use, a more decentralized view. So traditionally, you have an HTML front end, a web browser, a web server. You've got some APIs and talking back to a database. In the decentralized world, you have what's oftentimes called a decentralized app or DApp. That talks to some application running oftentimes in the cloud, and that application then makes use of the smart contracts that are deployed to the blockchain network. And that's where all the critical business decisions are made. So any agreements and stuff like that are all embedded in this smart contract. I'm going to skip this. I think you guys hopefully know this. This is very different than a secure data center or replicated data. The biggest issue is that in any of these kinds of scenarios where you have a single point of control, that means you also have a single threat point where somebody with sufficient privileges can make whatever changes they'd like to make. So a replicated system is likely just to replicate any of those kinds of changes, whereas a decentralized system, each of the parties has their own data centers, their own peers, their own nodes, and they're run by separate people. So the ability to be able to hack that is much more difficult. So you have this notion of in our world, let's say with permission blockchains, then you have this notion of identity management, because you have to know who the participants are in the network. This is oftentimes for legal reasons, for things like know your customer laws and anti-money laundering laws, but there's a number of reasons where in the B2B world, you have to know who's participating in the transactions. You also get a shared ledger, though, so everybody has the single point of truth or a single source of truth, and that's because the data is replicated across all the participants. The business terms are automated through smart contracts. And the execution of those, at least in our environment, is done through basically multi-party endorsements. So you have to have a certain, we're based upon Hyperledger Fabric, and so you have to have a certain number of participants in the network agree that the transaction is valid before the transaction is actually committed. We also then make sure that there's an ability to be able to provide privacy and confidentiality. One of the big things about blockchain networks is, if everybody has a copy of it, then everybody sees everything. Well, that's not necessarily the case. You can use various mechanisms to be able to hide information from some parties and share it with only other parties. So blockchain allows that to happen in a very declarative manner. And again, proof, this is a key piece here, is that all the transactions are signed. So you know who originated the transaction and who the participants are based upon who endorsed that transaction. So these are the models, basically. So everyone's familiar with public blockchain. That's Bitcoin, Ethereum, likewise. Private blockchains, I don't like the term. That's why I tend to use the term permissioned blockchains for these various ones. But the one we're focusing on is what are oftentimes called consortium blockchains. So these are a set of businesses that get together and they want to be able to both cooperate and compete. Co-opete? I don't know. I heard somebody basically coin a term to reference that. I thought it was pretty cute. But basically, the idea is that there's multiple organizations. The control of the network is done based upon consensus, and so you have multi-party consensus to be able to make any changes. And that also determines who's a participant, who's not a participant, who can authorize certain transactions, and other things along that line. So why are enterprises looking at this? So one, you get algorithmic trust, right? You can't, if you signed a message and you signed a transaction, you can't say you didn't sign it if I've got a copy of that message with your signature. So you get this non-repudiation. So that also helps then reduce the risk of fraud. It's tamper evident, not necessarily tamper proof, but certainly tamper evident in case there's any changes to it. And as well, then the process about what the business processes are often encompassed in these smart contracts. So that's all algorithmically controlled and not dependent upon people's actions or inactions or mistakes. You get a single source of truth. This is a really big issue because oftentimes in these kind of business environments, you have your source of truth, I have my source of truth. Now we have to go through this reconciliation process. And that's oftentimes done offline in batch mode. So there's inconsistencies necessary between what you see the world and how I see the world. With blockchain, we have a single source of truth. So there's only a single record that we all see. So you get in, and also you get a full audit history because you see all the changes that are made to it. As I mentioned, there's not necessarily a need for intermediaries. There may still be, but in many cases you can eliminate intermediaries. If I were banks, I'd really be concerned about this. So you get, and as well, you get lower transaction costs because without the intermediaries, your expenses are decreased. You also then, as I say, get real-time reconciliation. So you have the actual state of the world in real time whenever you need to access it. And it's available to multiple organizations. And essentially this is a mechanism because it's all automated to reduce error and fraud. So we're based upon Hyperledger Fabric. We made this decision back in 2016 or 17, just as it was getting started. And largely it's because it was the only what we saw scalable permission blockchain available at the time. We still think that's probably the case. Most of the current blockchain development has largely been focused on public or permissionless blockchains, and not as much new developments going on in the B2B space. At least that's what we're seeing. Excuse me. So the system chain codes are programmable, so you can develop these smart contracts. It's scalable. It scales much better than any of the permissionless blockchains because when you know the number of participants, you know all the participants in the network, you can devise consensus algorithms that are far more scalable and far more performant than things like proof of work or proof of stake. It also has built-in, confidentiality features. You can do channels to segregate traffic between different participants. There's what are also called private database collections and private collections. And as well, a lot of the components were pluggable and extensible, which was a feature that we really liked because Oracle wanted to build upon it. So what were some of the challenges though when we picked this up? So we looked at this and we go, okay, we got Fabric, what do we need? Most enterprises already have built-in information systems and that has to be integrated. That's pretty difficult to do if you're using things like proprietary protocols that are low-level protocols, things like gRPC and stuff like that. That's just not typically supported by most ERP systems. There wasn't a lot of production readiness. It was difficult to actually get the systems into production, required a lot of command line tools and stuff like that. And as well, what we found is that customers would do this and then they were left with the issue of how do I upgrade, how do I perform maintenance, patching, all those sorts of things. And then as well, there's the issue of any consortium. The issue is how do I form this consortium? Who are the members? And how do I control who those members are and stuff like that? So that's also been an issue, and that's one actually that we're still working on. So we're trying to help customers build on this. And so one of our first customers was what's called the Global Shipping Business Network. This is a consortium put together by a company called Cargo Smart. And the issue here is that there are lots of different players in international shipping. So in the shipping industry, you've got suppliers, you've got the ports, you've got the ships themselves, you've got many different parties involved in this. And so what they did is they got these parties together, formed this consortium, and then built a blockchain-based application on top of that to be able to speed up the operations of global shipping. As you can see, they've got about 300 customer groups. They've got about 40 million blockchain transactions they've done so far. And then, this represents about 1.7 million shipments. We have some other, use cases here where we're outside of the supply chain. So Jordanian Bank becomes a leader for cross-border transfers. And we also have a lot of customers who are focusing on things like know your customers as a service. So you've got eKYC services and things like that are being developed. And finally, in supply chain, one of the biggest issues is around ethical sourcing of materials to ensure that materials are not coming from conflict mines and things like that. So conflict minerals are able to be tracked and prevented from being able to enter into the supply chain. And I'll talk a little bit more about that use case. Blockchain is also being used in COVID. So at least in the COVID fight. So one of the projects that's been developed is a consortium of both enterprise providers, so blockchain providers, so IBM, Microsoft, and Oracle have gotten together and built a system called MiPasa, along with a number of others who provide sort of the technical background behind it. But it's basically a way to be able to share data sets and authenticate the validity of data sets and be able to use those data sets for doing research. So this is something that was done basically using the Oracle's blockchain, the Hyperledger Fabric, and then we tie those together with the Microsoft and IBM platforms. Another one is Health and Human Services is using our blockchain service to be able to track the results of test results for COVID. And as well, then we have others that are doing things along the lines of self-sovereign health certificates. So this is the ability to be able to, people have talked about this like vaccination passports and things like that. So the ability to be able to certify that I've met certain health requirements before travel or otherwise moving about. And then as well, we've got another opportunity or another project that's underway to be able to track the distribution of COVID-19 vaccines. So you can see even though it's a short period of time here, a lot of this stuff has been able to put into production. And that's, I think, pretty impressive given that COVID only is a little over a year and a quarter old. So what is it about the Oracle blockchain platform? So we see that organizations are going to more and more are going to work together. They already work together. They're already doing B2B transactions, but we want this to be transformational and basically allow them to optimize these networks of business interactions that they have. So by providing a mechanism for trusted transactions to be able to be exchanged between organizations, we can get down to this single source of truth. What we want to do is we want to make it easy and quick. Well, one of the things we found about blockchain is that it's a lot of work to set up a network, especially when you want to set up a network that's going to be participated by multiple parties. So we've focused an awful lot on that. We want to build this into our cloud and also on-premise offerings because we have a lot of situations where where data cannot cross national boundaries. So a lot of countries have data protection requirements, and so if you're going to process their data, you have to process it within their country boundaries. So we don't have, or anybody has, enough data centers to cover every country. So in those cases, then we're proposing, or for other cases like government cases, stuff like that, we have an offering that's based upon an on-premise solution that maps very closely to our cloud-based offering. And the other thing that we're doing here is we're embedding this technology now into some of our SaaS offerings. So our ERP offerings are starting to incorporate blockchain technology, and I'll talk a little bit about one of those called Intelligent Track and Trace. So we want to make it easy to deploy. This is a critical part. You can play around with the development tools and stuff like that. You should get out of GitHub and stuff like that for working with Fabric. But transitioning from that into a production environment is an incredible amount of work. So we make it very easy. And effectively, a minute you can start the deployment of a blockchain network, and 10 or 15 minutes later, that blockchain network is up and running. We wanted to make it easy to integrate with other systems of record, such as ERP systems and things like that. So we provide a set of REST APIs and client SDKs to be able to do that. We wanted to make it easy to secure. So one of the things permission blockchains need is an identity management system. So we've integrated the Hyperledger Fabric membership service provider into the Oracle Identity Cloud Service, or IDCS. As well, we're providing libraries for things like what we call fine-grained access control. This allows you then to be able to say who should have access to what kind of information inside your blockchain at a very fine level. We've also provided things like a management console, make it easy to manage and monitor it, and integration with logging tools and the rest of those sorts of things that you expect in an enterprise environment. And then finally, try to make it very easy to add new members to the network, because one of the things that's going to happen in most blockchain networks is that it's going to evolve. New members will be added, old members will be removed. We try to help automate all of that. So as well as I think we have this growing level of applications that are built on top of it. And as well, we've just recently introduced a set of tooling that is an extension to Visual Studio Code and also a command line tool to allow you to build applications based upon a specification file. So you can, So you can define a set of assets and the operations that are performed in those assets, and this tool then will generate pretty much everything but the actual business logic that's necessary for those operations. So it makes it very fast. You can typically prototype applications or pilot applications in a matter of days or weeks. As I mentioned, we have both a cloud offering and a platform on-premise offering. The biggest difference, the cloud offering, is what we call a managed service. So Oracle takes care of the patching, the upgrading, the monitoring of it, make sure that it's highly available, all those sorts of things. The on-premise version is you use it wherever you want it, you deploy it, you manage it, it's up to you. You can run it in your own hardware or on other clouds and stuff like that. Then, as I say, we have the Intelligent Track and Trace. This is a pre-built application to be able to allow you to, in our cloud ERP application, to be able to track the movement of materials in a supply chain. And then finally, there's another feature here that we're developing called blockchain tables. This is a lot like Amazon's Quantum Ledger DB. Basically, it provides a set of tables that are effectively immutable, and they're chained together much like a blockchain, but it's a centralized as opposed to decentralized solution. Real quickly, the components of Hyperledger Fabric, if you're not familiar with it, is that you have, first you have the membership service. So the membership service determines who are the participants in the network. That holds such things as their public keys, what organization they're in, all this sort of information. There's the application, which is typically built upon an SDK or a set of REST APIs. And it's the one that actually then making the submission of the transactions to the network. It sends what's called a proposal to the peer, to one or more peers. This is controlled by some policies. And then the peers execute the smart contract and return the results. And then if sufficient peers endorse the transaction, meaning run the smart contract, get the exact same identical results, that is then submitted, the results of that is then submitted to the ordering service. The ordering service places that transaction in a block and then sends that out to all the peers. So that's how the propagation happens. And the ordering service then basically is just responsible for ordering, whereas the peers do the validation is a separate step. So it's a little bit different than some of the other blockchain networks. A little bit about, as I say, our cloud service. I'll talk about this really quickly. It's pre-assembled. We're based upon Hyperledger Fabric. We integrate in with our on-premise editions as well as other third-party applications. So in the case when we did with MiPasa, we integrated with other Fabric implementations. We also then provide integration mechanisms. We provide then some of the custom apps that we're starting to provide, or the SaaS apps, and customers are starting to build custom apps. And we're starting to build up a list of third-party apps that run based upon our ledger. A few quick things. I think we got time. Very quickly, we, as I say, it's pre-assembled, so provision and integration happens automatically. You don't have much to do. It's managed, so we take care of things. The identity management integration, fine-grained access control I talked about. This bidirectional gateway, this is the REST API. So this provides both the ability to submit transactions, get the results of transactions, get notified when transactions have been committed. All that sort of information is all available through a set of REST APIs, making integration much simpler. I mentioned the management console. One thing we did technically is we replaced LedgerDB with Berkeley DB. That allows us to use SQL queries instead of the couch query language, which is much more powerful. And as well as we call this rich history database, where we take the transactions and siphon them off as they're committed to an Oracle database instance. And I'll talk a little bit about why you might want to do that in a second. Yeah, so we have a console. Everybody's got to have a console. So we have one, takes care of the administration, configuration portions of it. It takes care of lifecycle management for things like deploying and instantiating smart contracts, and then provides you as well monitoring and troubleshooting views to be able to get access to logs and all that sort of stuff. I talked about that already. So this rich history database, this is an interesting feature that we came up with, which is basically we have a lot of customers are starting to ask, well, now that I'm doing transactions on blockchain, I want to be able to perform analysis of this. So I want to use BI tools or analytics tools to be able to analyze those transactions. Well, a blockchain is not a normal database, so the standard BI tools can't access the data inside of a blockchain. So what we do is we asynchronously update a table or a set of tables in an Oracle database instance with the transactions as they're occurring. And then those transactions then can be analyzed using pretty much any kind of business intelligence tools you'd like to use. The Enterprise Edition, as I say, it's simply a version of our blockchain service, but it runs in your own virtualization environment. So it's deployed as a set of virtual machines, but you're responsible for the configuration and deployment of it. So it's an on-premise offering, although it can run in third-party clouds. Interoperability is another big piece that we wanted to focus on because, as we like to say, blockchain is a team sport. So you need to have multiple vendors involved, multi-cloud involved. So we support this. So we support interoperability with different Hyperledger Fabric implementations or different places where our software may be running, and we ensure all that all works. We're starting to build some frameworks so we can run Solidity smart contracts and we can run DAML smart contracts with third-party support. And as well, then we're starting to work on things like cross-ledger integration. And so cross-ledger transaction integration is one of the big, I'd say, remaining real problems. And there are some techniques for that are being developed. And so we're working with customer or partners right now to develop that. Yeah, MiPasa, as I mentioned, so we've got we have 4 different vendors providing different services and stuff like that. You can go look up MiPasa and find out more information about it, I'm sure. Our blockchain app builder, so essentially you define what's called a specification file. This is basically a set of assets and their properties and the relationship between them. That then is used to generate the smart contract code in either Go or TypeScript. And then you can deploy that locally and test it locally on your own machine, or you can deploy it and test it against an Oracle blockchain cloud instance. I want to get into examples and solutions and stuff like that, because I think that's where a lot of the interest here is, and I think I'd like to have some discussion around that. So without further ado, as I say, our platform is built on top of the Oracle Cloud infrastructure. Although you can do things like deploy the Oracle Blockchain Platform, the Enterprise Edition, on other parties' clouds and stuff like that, or your own hardware. I mentioned already the custom apps. So we have what's called a solution engineering hubs. These, and also as well as something called a startup program. These work very closely with new customers who are trying to apply this new technology and help them get through basically through the pilot and POC phases. Mentioned as well, we have things like integration with our various SaaS applications. So at the moment, we have applications integration with our open banking API platform, with our FlexCube core banking application, and part of our ERP application, Oracle Intelligent Track and Trace. So we're starting to see much uptake by Oracle's own SaaS offerings for this technology. We have a lot of SIs that are helping us build and deploy to customer applications, and as well a lot of ISVs who are building applications for them to resale or to be used in anybody's Fabric implementation. So some of the use cases, so this actually information is a little old. We're probably more like closer to 400 customers and 300 trials. But some of the use cases that we've encountered outside of supply chain are things like financial services. So cross-border transfers is a common place where blockchain is being used or being looked at being used. Loyalty programs. So I want to take my Marriott points and go down to the local Starbucks and get a latte, but I want to use my Marriott points. These kinds of exchanges and stuff like that for loyalty points are an excellent application for blockchain. And we're seeing a lot of interest in the hotel and transportation and hospitality industry. Also, asset securitization, tokenization, I'll talk a little bit about that. But people want to be able to define assets in such a way that, and using tokens to be able to represent those so they can be exchanged as needed across the blockchain and tracked across the blockchain. I'll talk a bunch about some supply chain use cases. I'll get to those in a minute. I'll go on to, so public sector, we're seeing, things like customs and taxes and stuff like that. So the government wants to be able to use this to be able to track things like shipments and the customs that are associated with those shipments when they arrive. Taxes, digital assets tracking for things like artificial intelligence and machine learning. One of these we believe is that AI and blockchain are going to become very closely tied together, because the validity of a training set for machine learning algorithms is critical. If you can't verify the data that you use to train the algorithm, you have no idea whether the algorithm is any good or not. So being able to track the provenance of data sets is something that's going to become critical in the artificial intelligence world. At least that's what I believe. Healthcare and pharma use cases. So we have a number of these. Some of these you've already seen in terms of what we're doing around COVID. But anti-counterfeit drugs is a huge issue. I've heard numbers that say that in India, as potentially as much as 25% of the drugs dispensed there are counterfeit drugs, maybe even higher. So supply chain, in the pharmacy industry is a huge place. Other areas we're seeing, in supply chain. So we have example is Cano. They're tracking leather sourcing and making sure that the materials are sourced correctly. That that they can track how those materials were provided. Circular, I'll talk a little bit more in detail, but this is around sustainable sourcing of minerals that may be mined in conflict areas. We have a number of food use cases. So certified origins is a good example. They provide extra virgin olive oil, and so they track the olive oil from the time the olives are grown to they're harvested to they're pressed to they're bottled to they're shipped until they're finally end up in the retail store. So this is really farm to table kind of tracking, which has become very popular for people. We also have things like luxury goods. So Everledger, this is the reference that Brian Bellendorf was making. Everledger, and I'll have a little bit more about this, but Everledger provides a mechanism to be able to track diamonds from the time they're mined to the time they're set in a ring. I'll get into a little bit how they do that because I thought that was kind of interesting. Beretta, another one. They sell very expensive firearms, maybe as much as $100,000 or more. And so they want to make sure all the materials and all the workmanship and everything else that goes into this adheres to their practices and their claims. We have transportation logistics. One of, as I mentioned before, CargoSmart. That's one of our largest users. This global business shipping network. So this is, how do you automate the transfer of information and the exchange of information and agreement of information in the shipping industry? Then finally, we have, another area here is, online training, education, certification. So this sort of almost crosses over into some of the public sector stuff. So things like licensing or things like transcripts for university enrollment, all this kind of information that would be really ripe to be able to be put on the blockchain, to be able to allow controlled access to this kind of confidential information. Some more, financial services. It's really big. Outside the Bitcoin world, it's still really big blockchain. So we have a lot of work that's being done in this area. We're also expecting that the central bank digital currencies that a lot of the central banks are starting to look at and investigate are likely all to be built on blockchain technology. So with that, let me talk about a couple of these. So certified origins, as I mentioned, this is one that's, this is tracking the supply chain for olives in Italy for a premium brand of olive oil. And so what they want is they have keeping track of information, but much of it was manual, much of it was paper driven. And what they wanted to do was to be able to automate this, improve the quality of it, ensure the quality of the information and quality of the olives and the olive oil that's being produced. So here's a quick little video from them. It's, by the way, it's in Italian, but it is subtitled in English. Sorry for all the non-Italians. Oop. Sorry, getting used to embedding video. So another use case here for traceability is around conflict minerals. So this has been a big issue over the last few decades in that a lot of raw materials, especially high value raw materials, often come from countries where the mines may be controlled by corrupt governments or other elements where the conflict and the funds from that are being used to fund those conflicts. So being able to get those out of the supply chain is a critical piece of being able to try to calm things down in some of those conflict areas. So the traceability here is for circular is to be able to track the flow of cobalt, which is a rare element used, or an element used in the production of batteries and other components. So here's another little blurb from them. And finally, the one that was mentioned today by Brian Bellendorf is around Everledger and their ability to be able to basically track diamonds from a mining to the point where they're actually provided on a set in a ring or something along that line. So real quickly here, and then we'll get into some of the question and answer, I guess. I'm sorry for a little bit of selling there. I was pulling these out of some decks. So in any case, let's get to, I guess, some of the questions here, since I'm not going to cover all these other use cases. We have many, many, many use cases, but let's get on to the questions. It looks like there's a bunch of stuff in the chat, although I don't know how many are questions.
Yeah, so one of the first questions we had from Salmia was, what kind of coding is needed to work in blockchain?
That's a really good question. So there's two parts to almost every blockchain app, at least in our world there is. So there's the blockchain smart contract. That's the code that embodies the business logic that's to be adhered to. So that code, at least in our platform, can be written in Go, TypeScript, or JavaScript, or Java. So you can provide, or now with some of our third-party integrations, things like DAML and Solidity. So those are the languages to write the smart contract. Then there's typically the application that actually makes use of that smart contract, because smart contracts is not a place for user interface or integration type work. That's something that's typically done external to the smart contract, to the blockchain network itself. So in that case, you can use almost any language. Typically, we see customers using Java, Go, whatever, anything that can basically invoke a REST API, or anything that can use one of the Fabric client toolkits.
All right, thanks. Another question we have from Puneet is blockchain still considered an up and coming technology, or is it seen as like legit in the corporate world?
That's a really good question. I think it varies. the folks that are coming to us are a mix. We have some that have got solid blockchain plans. They understand the issue. They understand how to create a consortium and do all that kind of work. We have others that we talk to, and sometimes they don't get it. So it's the legitimacy of it is growing rapidly, but it's still considered up and coming by a lot of customers, I think. Even though we have, as I say, we have customers that have been in production for several years now, and so is that not working? It seems to be working for them. I think the biggest issue is that the technology is going to continue to evolve, and so that's a potential problem, right? If you're building on one platform, and let's say 2 years from now that platform is no longer being supported by anybody, you've got issues. So it's a rapidly changing environment. So that is also, I think, may make some companies hesitant about to be able to adopt it. More questions?
Yeah. So from the Ben organization, we have how does GDPR affect Oracle's blockchain deployment?
Oh, that's a really good question. GDPR is a pain in the butt. For us, actually, for Oracle itself, it doesn't make any difference at all because we're not the custodians of the data. The customer is, but GDPR definitely impacts blockchain development and deployment, right? Since you can't remove a transaction record, it obviously can't hold anything that is under the right to be forgotten regulations of GDPR. So that makes life very difficult. Typically what's being done there is used what's called off-chain storage. So off-chain storage is data that's stored someplace else, maybe in IPFS, maybe in an Oracle database, maybe anywhere else, maybe in a file system. Doesn't really matter. And then what's held on the blockchain is some way to be able to link or tie back to that. And even that has been questioned, I think, by some of the GDPR rulings. But that seems to be the best approach. So that kind of data that falls under the governance of right to be forgotten can't be stored directly on the blockchain. At best, as I say, a reference to that data can be stored. So GDPR is a big impact. It means that we'll probably, well, I don't mean, we may never get to where blockchain's the only source of data. We're obviously going to have sources of data where data can be deleted.
All right. From Fabio, yeah, he asked, will blockchain replace a large portion of legal contracts through the use of smart contracts?
That's another really good question. And there's a huge amount of debate about this because the issue is that lawyers don't write code and coders don't write law or interpret law. I think there's always going to be legal contracts, but I think much of the detail of the legal contract can be automated. So it'll still be in place, but it will exist in forms of smart contracts and things like that. But I don't think we'll ever completely eliminate legal contracts. There's too many nuances and issues around that. At least that I can foresee. Maybe we'll get to that point, but legal contracts are written with very specific legalese and legal terms that have specific meanings, and trying to translate that meaning into code is a non-trivial task. We can see how to do that for things like invoicing and things like that, but when you start to get into late penalties or even things much more convoluted than that, or complicated than that, then I think it's going to be difficult to say that everything sits inside the blockchain network. So I don't think that'll happen, at least not in the near future. Obviously, we want to get away as much as possible from legal contracts and legal disputes as well, right? So that having a single source of truth helps eliminate some of that.
Awesome. So another question we have is from Puneet again. How does the Oracle blockchain application compare to the AWS blockchain application?
Okay, I'll speak. I don't know a lot about the AWS one, but and it may have evolved. I think the biggest difference was, at least when I last looked at it, AWS, they basically would provide you AMIs, Amazon Machine Images that contained Hyperledger Fabric, but managing it, configuring it, deploying it, and all the rest of that stuff was all left to you. That's a lot of work. If you've ever tried to put together a Fabric network, you've got all this crypto material that has to be exchanged. It's all got to be put in the right place. You have to have a Docker network in place to be able to deploy the Docker images and manage and monitor all that. So at least as far as I know, Amazon was not what we would call a managed blockchain service, where the Oracle one is a managed one. So, you know, as new versions come available, we take care of migrating your data. We take care of upgrading your instances to the newest versions and all that sort of stuff. So that's why we call this a managed pass offering as opposed to just a plain pass offering. Does that help?
Yeah, thank you.
Okay.
We have from blockchain again. What are some examples of ISVs using Oracle's blockchain?
Yeah, so the ones, pretty much all the ones that well, I should say that that's for ISVs. I'm sorry, these are end customers, most of these. So Circular and Retrace and some of these other ones that are doing sort of the provenance of materials tracking in supply chain, those are ISVs that are basically, they offered for a variety of different consortiums. They're not providing a service themselves, they help build services. So I'm trying to think of the ISVs in particular. If let's see here, I think we should have a list. I can get back to you. I'm not quite sure which all of ours are ISVs versus which ones are in solutions themselves, right? Offering the network themselves.
All right, thanks. And for our last question, we have from Henry. Since Oracle's blockchain is permissioned, what's your method of achieving consensus?
Well, that's a really good question. We in Fabric, consensus is largely a two-part operation. So there's the consensus about the validity of the transaction. And so that's determined by what's called an endorsement policy. So when you propose a transaction, say to transfer money from account A to account B, that's going to get executed by a smart contract. That smart contract is going to produce some transaction results. That smart contract has to be executed by some number of peers or some number of participants in the network. How many is determined by a policy. So that could be 1, it could be 5, it could be a majority, it could be 90%. That's a decision that the blockchain network has to make. How many copies do you want to make sure are giving you the exact same results before you agree that the transaction results are valid? So there's a transaction validity portion of it. And then there's also then the ordering of it, right? So transactions in a block have to be put in some order. And the order that they're put there might be important. In most cases, it's not typically important, but you have to put them in a block. And so that's done by an ordering service. So the ordering service takes the proposed transactions that have been endorsed. So there's consensus about the outcome of the transaction, but just not the ordering of the transaction. And then there's also an additional hiccup in that your transaction may have been valid at the time it was endorsed, but it may no longer be valid because the state of the database, basically the state of the blockchain, has changed. So if I update a record and you update a record and they end up in the same block, at least in the Fabric world, one of those is going to fail because it read stale data when it was endorsed. So the endorsement policy makes sure that the data is consistent and agreed upon. The ordering service makes sure that they're placed and everybody executes them in the proper order. And as a result of ordering, then things may get invalidated. So transactions may have to be resubmitted. And that's because Oracle uses what's called multi-version concurrency control, or Fabric does, I should say. So the consensus is largely around, say, making sure you have enough members that you think you need to agree upon something. It's not a fixed number. It's all policy driven. So I could say I want 4 admins from one organization, 2 other users from another organization. They have to endorse the transaction. Otherwise, it's not considered valid. And then again, if the data validity portions of it, multi-version concurrency control, may also make it invalid. So does that help? It's very different than most of the other consensus mechanisms that are out there. And as far as the ordering service, that's really where the consensus occurs. That's where at least the consensus algorithm is used. And right now, what we're using is Raft. So we use a Raft-based ordering service, which is a leader-based consensus algorithm. It's not Byzantine fault tolerant, but Byzantine actors can really only do 2 things in the ordering service. They can only front run, so they can choose the order in which transactions happen to their advantage, or they can censor, so they could drop or not process certain transactions. They can't alter transactions because the transactions are signed, and so the transaction validity is guaranteed. So the ordering service has minimal capabilities in terms of messing things up, but we're still working on, Fabric is working towards a PBFD, practical Byzantine fault tolerant algorithm for the ordering service. So once that's available, then we, you should be completely protected from Byzantine actors. If I can still answer, there's another question there from Henry.
Okay. Yeah, it's fine.
So he's asking, is the endorsement automated? Okay, or does that need to be manually done by an administrator or user? The adherence or insurance of adhering to the endorsement policy is automated. What has to be defined is that policy. So for every smart contract that's deployed, you can specify what that endorsement policy is. So maybe I want 80% of the users in my network to have to agree to it. Or maybe I only need 5 of them because we're big corporations, we're big boys. We don't probably have a chance that 5 different organizations would all be inflicted with some issue or something like that, have some sort of security violation. So that's one thing that also makes it very scalable. You don't have to have everybody execute this. The only thing that gets executed by everybody are the updates to the database.
All right, thank you. Thanks a lot, Todd. That was really informative.
Good. I hope this is what you guys were looking for, I hope.
Yeah, definitely.
Oh, good. Okay, awesome. So if you like, by the way, you can reach out to me by email. It's just todd.little@oracle.com. Go to Oracle. I've got a slide. I should be showing the slide. Just some other pointers, basically. So if you want to get more information. So more information about our offering. It's available for trial and stuff like that. I didn't mention, but it worthwhile is that since you guys are in college and stuff like that, we do have a very active startup program. So Oracle works very closely with startups to try to do POCs, try to figure out how to evaluate and use the technology. Very much focused on helping startups get up to speed using the Oracle technology. So thank you. I hope that was informational. I hope you guys learned something. And to say, if you have any questions, don't hesitate to contact me. And with that, thanks.
Yep. Thank you so much, Todd. It was a great meeting. If you don't mind staying on for just another minute or two, we are going to give all of the club leaders out there a great opportunity to get some great promo material. If anyone that is comfortable with it can please turn their cam on now. All those club leaders can take a quick flick of all of our wonderful faces here. If you go into gallery view on your Zoom, I know 100 people meetings don't come around often, so this would be a great opportunity for that. So we'll give 10-15 seconds for people. Say cheese, smile. Okay, that should be great. Thank you, everyone. Another like quick 15-20 seconds. I think some other people at Rutgers Blockchain have something to say.
Yeah, thank you, Chris. I would first like to start by thanking everyone for coming out tonight. I would like to specifically thank Todd for his amazing presentation, the many Rutgers clubs for attending, Elon University for joining, and Ben for helping us set this all up. As a quick note, our e-board applications were extended to tomorrow night. If you're interested in working with the board, setting up events just like this, and traveling to the different hackathons we attend around the nation, get your applications in by tomorrow night at 11:59 p.m. The link to the application can be found on our website, and as well will be posted in the chat. Additionally, we'll be working on creating a supply chain initiative at Rutgers. If you're interested, we'll be sending out an email later tonight. The link for those interested will also be posted in the chat. Any club that would like to drop their GroupMe and contact information, feel free to drop it in the chat. Please limit your entries to 2 responses so we don't spam the chat. And now I'll hand it off to Ben to close out the meeting. Thanks, everyone.
Can we try the screenshot again? It seems like a lot of people weren't able to turn their camera on. So if you re-enable that, for attendees, we should be able to.
Anyone wants to turn their camera on, the setting was being weird, but I think it's working correctly now. So whoever wants to, get your cameras on. All right, gonna take a picture now. Just get another page of you guys. Alrighty, thanks guys.
Okay.
Well,
we will
thank you
be
again,
posting-
Todd. Everyone at Elon, I know really enjoyed it. So hopefully my audio is working now. I apologize
Yeah,
for the
that
beginning
is.
there. It was fantastic though. Thank you. Thank you again.
Well, thank you.
We'll also be posting an invite link in the chat to our Ben group and our Ben USA group. Network of students across the world, as you heard at the beginning of the call. Elon and Rutgers are just two of our most active clubs, but there are many more clubs, East Coast, Midwest, West Coast. So we're going to do more intercollegiate events across more universities in the coming semester. So be sure to register for those groups. And also our newsletter is at blockchainedu.org/join. And in there, you'll be able to get all of our opportunities, all our resources, our events. And when we have free tickets to conferences, free flights, free Airbnbs, you'll get those as well.
Yes, real points will be going up now. And if all the clubs involved would want to drop their invite links to join the groups, that would be appreciated.
All right, you guys should see the real points on the screen now.
All right, well, I think that's all from us tonight. Thank you so much, everyone, for coming. And thank you, Todd, for making it tonight. We really appreciate it.
Yeah, happy to do it. Glad you guys happy with it. So again, any questions, don't let me know. Let me know. Don't let me know. Let me know. So.
Yep. Email is in the chat.